My name's Dan Conn. We're going to talk today about something that happened quite some time ago. At the moment, a little bit about me. I work as a developer advocate for a company called Sonatype. You might have heard of them. We're not the company that's a sponsor. They often get confused the two. Worked around the security space. Well, I've worked as a developer for 10 years, but with a very long interest in cybersecurity, mainly from this incident, which is what we started. I've studied it academically. I've never been on Celebrity Love Island. That's a different Dan Conn. Apparently is much younger and much better, a lot of things. If you want to get in touch later, those are the links to follow, please do. So what we're going to talk about today, we're going to start off with a little bit of why we should care about security. Then we're going to go into the hack. And then we're going to kind of have some lessons learned around what we found on that, and then hopefully some time for Q&A. So, who cares about security? And more to the point, why should we? So yeah, who does care about security here? Oh, that's good. That's a lot of you. Who is here that doesn't have developer or security researcher in their job that still cares about security? Oh, a few. Okay, that's good. So, I think this is the main thing. Like, let's see how much you care about security, though. Okay. Have you heard of vulnerability management? Oh, only a couple of you. Has anybody heard of secure coding? Many more. That's okay. That's a good start. Has anybody heard of disaster response? Brilliant. Okay, so I'm not preaching to the unconverted. So I'm going to start with this by saying the reason why I was asking, security is actually for everyone. And it shouldn't actually matter what job title you have in a company. You should all really care about it, and you should all try and learn enough about it. And why is that? Well, we all make mistakes, every single one of us. And that's a terrible premise to start a talk with, right? Everyone makes mistakes, we need to learn something. But I think it's all right. If we look at Forbes, this came out about 6 months ago in 2020. Well, no, about a year ago now. Crikey, time flies. But 83% of small and medium-sized businesses, they would basically buckle under a cybersecurity attack, mainly because of financial pressures. If they actually were to have something and they hadn't prepared for it, it would cost them their whole business, either through the loss of data, the cost of rebuilding what they have, or the cost of just simply reputational damage, which is another huge factor. So, a very famous president once said, by failing to prepare, you prepare to fail. And that's great words. It's a great thing to remember when you're thinking about security. And so goes my first mistake in this talk, which there's going to be quite many. There's someone called McCormick who actually found that Benjamin Franklin never said that. Sometimes throughout your career, you might do things just because somebody had told you to do them, and not actually because you know for sure that that's actually what the initial message was. So, we all make mistakes, and that's fine. It's absolutely fine to make mistakes. How many people here has made a mistake in their career? Yeah, that's good. How many of you owned up to it, or had an environment where you could own up to it? Much less. And that's what we find. Sometimes you work for a company that says, I don't want to know about your failures. If you fail someone, that's it, you're fired. And that's a really toxic way to live, because the only way you learn is by making mistakes. As long as you don't keep repeating them, you've got to learn something. But actually, repeating the same mistake isn't learning. But actually being able to have an environment where you can actually make mistakes in the first place is incredibly important. And this whole experience for me was my learning how to make a mistake. We're going back to the very start of my career. I was a junior mid-level dev, and I went into work one day, and this is what I found. No cybersecurity knowledge at this point. The people that were my senior developers, they had no cybersecurity knowledge. We were a team of 7, and what we were in charge of was a global business's technology. Does that sound familiar with anyone, that kind of ratio? Yeah, okay. So let's go. So a little bit of a disclaimer. although the events did happen, times and names been changed to protect the people that actually it happened to. I'm not really into naming names, that's not on. The vulnerability and the steps taken, they're very real. It's what I experienced. So, wish I had some casualty music right now, but never mind. So, let's start with our. Now, you might be familiar with this website. This has not been hacked as far as I know, right? Yeah, definitely not, yeah. But we're going to use this as kind of our example. Beautiful website. I particularly like that really lovely image. Essentially, this was what our website was very similar to, except ours was written in WordPress, written in, obviously then in PHP, backed by a MySQL database. It was deployed on a CentOS server. And it used a lot of plugins and dependencies. The reason for this was just an informational website. So many companies just have them as, here's my presence and the day-to-day. And you need that for a global business, right? It might not have any secure data, and this one certainly had no data that could be stolen that was personal information either. But it did have a huge presence. And it was very important this website stayed up and looked good. So imagine coming to work and seeing your beautiful website ending up like this. I've used some graffiti to similar, but that's how it felt like coming to work and seeing that, what the reality was it didn't even have these lovely images. It actually went to a completely different website that was poking fun at the thing that we were trying to protect. Not a good day. That was 9 o'clock in the morning. I come to work thinking everything was going to be fine, and I can tell you some 24 hours later it still was not fine. Defacement. It's embarrassing for the company that does it. We had no idea how it had happened to start with. And to make matters worse, we had no backups. So that's the first lesson of this. Make backups, if nothing else. So we stayed around for a long time thinking, how did this happen? We couldn't, at that point, even get access to the website again because whoever had taken it over had basically overwritten our keys. So we're stuck here, not really thinking how we're going to get access anymore. Well, that's the best thing about software. You can start again, right? It's still not great. But starting again actually gave us some time. It got us a little bit of breathing space where we could go, right, well, there's no data that needs to be restored. We're lucky in that stage. If you have data that needs restoring, definitely take backups. And regularly. And make sure, actually, that you check those backups because sometimes, very sturdy things like tape, if you've had them for 5 years or so, you might find some very weird things happen to them. And also any hard drive, they go stale and they can't be recovered sometimes. So in this case, we had a chance to start again. We could rebirth ourselves as it was and get the website at least looking back to this. And you can see some problems already. We might have the images, we don't have the data. So the next quite a long time was trying to get the website back to this. Hooray! Okay, we're back in business, at least there. And this also, behind the scenes, we're resetting keys. We're trying to figure out what's gone on. But at least as far as our customer is concerned, their website is back. Well, obviously, we've had to tell them what happened, but we can say that the site's back and operational. Well, what did happen? See, at this point, the people that I work with, they wanted to leave it at that. The website's up. Doesn't matter, right? Does that sound satisfactory? SLA's ticked? Well, no. It's really unsatisfactory because you don't actually know what happened. You don't even know if anyone's still in actually your server waiting to just do this again. So, and nobody really actually knew. They kind of thought, oh, well, someone's hacked it, but we've reset it. That's fine. So I decided to spend my spare time just basically looking through some PHP access logs and see if they could find anything. And a lot of it looked pretty like this, just GET requests. Until we found a file that essentially was trying to find something on an image website like Flickr, except it didn't have, it wasn't coming from flickr.com, and that's an example, it wasn't actually the one. It was coming from flickr.mybaddomainname.com. And it was trying to upload, instead of a pretty little image that we had used something for, it was actually trying to upload a PHP file. Accept all the things. It's not very good. So I've kind of skirted around the subject. What did we think we were actually making? What we thought we had was a WordPress site that allowed us to upload images using this really nice script called Tim Thumb. Tim Thumb's sole purpose is to just resize images. It takes from various, you can give it a file upload, and it will resize it to sit perfectly on your site. It will also go and take various images from the internet as well. And one of these is through the use of an URL. It will say, well, if you're from flickr.com, great. If you're from picasso.com, great. And so it restricts the domains it can be used. Kind of. See, what they actually did was kind of coded it rather naively, unfortunately. So if you put flickr.com.mybaddomainname.com, that was also accepted. Furthermore, they didn't restrict it to images as well. If you could craft a file. In fact, actually, at this version, you didn't even have to craft a file. It would accept anything. So PHP file, great. If that PHP file had some interesting stuff in it, well, you think, oh, well, just open it, right? Well, not really, because what this particular script does is that it opens files by running exec. So if anybody knows any PHP, that's pretty bad. It's essentially running that file. So you run the file, it's not uploaded, it's executed, there's your website gone. There's been loads of different versions of Tim Thumb. In particular, the most recent thing is that it's last worked on in 2014. So it's quite old now. If you do use it in your systems, don't. It's an abandoned project, what we call. It's primed for somebody taking it over, wanting to inject certain things or have some very dodgy things come out of it. And also, I think at the most recent one, it still allows for it's a little bit better that it doesn't accept every file, but it still allows you to point to a different URL, and then from that you can still perform remote code execution on it. This exploit in particular was found by two people, Mark Maunder and Makes. And yeah, how they did it, they got around it by creating the MIME type. Is anyone familiar with magic bytes, file signatures? At the start of each file, you have a certain amount of bytes in the first 8, and they are generally used to detect a MIME type. So for example, a doc file, D0CF1L, 11E, is basically every single Microsoft Office product known to person. JPEG has its other one, Zip has another one. And what this pretty cool exploit found was that actually if you create a load of hex digits that mimic an image file of any kind, and then you put different wrap some PHP code around it, the PHP code will still execute in Tim Thumb. So that was essentially what we found. It was incredibly difficult trying to piece together what that was. Could you imagine? I mean, I'm trying to think back. That alone took kind of weeks of me trying to research what happened. And it was all very It was all very difficult to kind of imagine when you don't know what incident response is. I don't think I slept for 9 hours straight. I think like what was lucky is that we had 3 other people that could take it over in the end. It's a very intensive role to try and do incident response, even if you don't know what incident response is. You're just going by feeling. Luckily, there's things you can do. You can actually learn all of this at universities like this, self-taught. There are loads of different ways of learning about cybersecurity. And in particular, there's also tools as well that can also help with that. OWASP, for example, they give a load of free tools. At the same time, we also have some free tools, but other companies also have loads of free tools that can help determine these things. One in particular is, and the OWASP Top 10 is a great way of learning about secure coding, because not only do they teach you how to securely code, they also show you exactly what to do, which a lot of resources don't. So, what actually have we learned? Well, hopefully we've learned it's all good to make mistakes. Hopefully we've learned backups are very important. And you can't trust dependencies. Like, that's the thing. It's like within what we had, like, even though we didn't know that, which we should have done, the actual problem was actually not within our code. It was within a piece of code within another piece of code that we had pulled into our project. Although you can't trust dependencies, you need them to be productive. Like, nobody wants to reinvent the wheel. It's a really slow process. Has anybody, decided to try to create their own API endpoint every single time they need to? No, it's just a waste of time when you can just pull something in that will do that for you. So everyone wants to create annotations every single time they want to create something from scratch. No, that's why they exist in language. Tools can help with that. Also, good access control. Why was the reason that our thing was actually something that I missed it on this particular part? But what was the actual reason that they could actually take over the whole server? Well, actually, because we had poor access control on that. If you have a file uploads folder, do you need 777 access to it, which gives you and the world access to that folder? Should it be, you need people to read to it? Well, why not change that to 775 so that you're not giving the whole world access to these things? When you're outside of the root of your website, you might even want to have a break folder where you're actually going to 640, which means that people can't delete it. And PHP is just today's example, but all languages have the potential for vulnerability. So Java would be vulnerable to this. C, definitely. C++, definitely. JavaScript, there are whole swathes of JavaScript and Python vulnerabilities around. Languages are tools, and you need to be aware of their security issues and when best to use them. PHP gets a really bad rep, I think, because everyone goes, it can't, it's loads of holes. And admittedly, I think at this time in PHP was PHP 5. So they realized they had an SQL injection breach in their validation. And the way they got around that, instead of backporting the method and saying MySQL escape, their method was called MySQL escape to escape thing suitable for parameterized queries. But instead of realizing they had made an error and backported it, they decided to slap real on the end of it. So use this one because this one's real, but we'll keep the old one still in there. There's worse things that have happened in languages. Every time that you see segmentation fault in C, that's because somebody hasn't thought about something very well, So I'm not saying PHP is a great language. I choose not to write with it myself, but it's not like, as far as security is concerned, they are all vulnerable. And even if you get everything right, some research done by Sonosite basically says 6 out of 7 vulnerabilities happen due to transitive dependencies. So even if your code's perfect, which it won't be because we all make mistakes, essentially you're going to find something. So it's actually good to kind of, if you're going to use open source, do some of these methods. So this is data from the OpenSSF scorecard. And what essentially we did was, this is also research done by Sonatype with AI machine learning methods to see if there was anything in vulnerable projects that actually made them worse, more vulnerable. And yeah, there's actually a lot of things that kind of stick out of essentially what this graph, it's a bit of a badly worded graph because although the research was on identifying vulnerable products, these are actually the things that will make your project a lot better. And the biggest one's actually code review. Who would have thought that, right? Just the ability to talk around your problems, to discuss that, and to say, is this actually a good thing? Inspect your code, inspect the code of other people, and actually, instead of treating it like a tick box exercise, actually say, yeah, that's great. Another thing is, next on the list, dependency pinning. Actually making sure that you're not always picking latest when you're pulling into something with your build tools. What's the other one? And then the other one is branch protection. So I think that's something when we're thinking about DevOps, we're kind of, let's let any branch commit, that's fine. What that kind of forgets is that some people aren't that far away into their DevOps journey yet. That involves a lot of testing. It involves a lot of coverage tests. It involves so many other things to make that happen. And a lot of people, when you look at their code coverage, sometimes it's at 30%, which is not great. You need then to go back a bit, do these code reviews, protect your branches, and make sure that this is good. I mean, you can fire from any branch, that's for sure. But you need these steps in. You need good quality gates to allow the security will still flow through when you want to speed things up. This is just a way that you can visualize things. So if you're ever wondering what your dependencies is, this is a free tool we give away right now called Bomb Doctor. It will actually go into your project, into your projects, and be able to score them. As I say, it's completely free. Have a play with it if you want. It's a great visualization tool on to how to get these concepts going. And if you're interested in the references that I did speak about, there's some there. Thanks for listening.
Thank you, Dan. Questions for Dan? We have time for, yeah, there you go.
Hello.
Hello.
In the last graph, you mentioned commits. What do you mean by that?
So this is actually, yeah, it's a good question, actually, because it's not very well explained. So what we find is, and this is something that we weren't really aware of until the machine learning tool kind of told us, is what you find is in commit messages, obviously, and it kind of makes sense, like counterintuitively, but what you find in a lot of projects that tend to go south or end up vulnerable is that you have a new committer, or brand new that's out the box. Now that might seem, what it might be is that over time they'll gain trust within a particular open source project, and then they'll get themselves to a stage of being able to commit more fully, and then at that point, that's when they might attack. Or, as we found, I can't remember the exact name of the project, but it was a JavaScript vulnerability about a few years ago, where essentially this organization, organized crime organization that actually hounded this sole developer of this open source project that was used quite widely in a lot of JavaScript tools, and they just couldn't keep up with the demands of having pull requests, like not actually pull requests, people demanding new features, and actually they didn't want to take it anymore. So they went, it's all right, we'll take it off your hands. We'll own it now. And then they put in a crypto miner. So great. But yeah, that's essentially what commits means. It's what you can see as a variation, or commits that have very generic messages. I mean, I'm guilty of that. Just fixed it. API, fixed it this time, I promise. It's probably quite a lot of people's commit history, but it also says that's probably a bad project because people aren't really thinking about it. They might be bulking in huge chunks of code into one commit, and then finding that that's yeah, that's a giveaway of why that's a bad project.
Thanks. The questions? No? No one cares about security? Everything is safe with you? Everything is secure?
Ooh.
Oh, sorry.
So, technical presentation first. And second, in this case, so we're talking of WordPress, so it's not really code that you did yourself, neither the plugins. So in terms of lesson learned and next steps, except the backup, do you have something in mind on how you could have improved the overall stability of this? Because I think a lot of people have those kinds of scenarios.
I mean, there is loads. I think in particular, like, yeah, backups would have helped in this situation. But I think as a wider thing is having what I call, well, what the world actually calls security champions. And having people that are actually hugely invested in the development process. Security by design is something that I'm hugely in favor of. That doesn't mean going to waterfall, but it means having security right there at the beginning, as opposed to what happens a lot of places where you build something, you release it, and then on the second release you might go through a security change, or sometimes months down the line, somebody might be asked to pen test it, they found it vulnerable at that point, and then you go all the way back to the beginning anyway. So you actually end up, in your agile process, actually ending up kind of waterfall anyway, because you haven't actually got security in there talking from the beginning. And I think that's, you know, I don't think it's something that you can automate very well. You can have tools that can help to automate things, but I think actually a lot of the time it's communication that actually helps with a lot of these things. One thing that in another company I worked at that was incredibly useful was threat modeling. Just from a perspective of, and yeah, not having just developers there, but having, you know, people in other parts of the business that might not even understand the tech, but they can understand problems, because actually they might have had something that happened to them in the past where they suddenly, that's their security trigger. And it might be something that other people that might actually work with tech day in, day out might actually think, oh, it never happened to us. And that's exactly why these things do happen, because there's a reason that the OWASP top 10 hasn't really changed in 10, 20 years. I mean, yeah, the positions of things have changed, but actually the same problems are pretty much the same for the past 20 years. No worries.
Hello, and thank you for the presentation.
Thank you.
My question is actually quite close from the one before. I was wondering if you have observed some impacts after this attack on the overall organization, like rise of awareness about security, I don't know, investment in new tools, like deep change regarding the way you were developing, architecturing this website, penetration tests campaign, I don't know, these kind of things. And from your perspective, what were the ones which were actually effective?
So yeah, you're right. And actually, I forgot to mention all that part of my talk. So thank you for reminding me. So I think, in the aftermath of it, there was one thing that I tried to do was say, hey, do you want to get involved in this? And a lot of people at that time, what you got to remember is kind of 10, 12 years ago, security wasn't a big focus like it is now. It was something that actually got in people's way, generally regarded. It was like a barrier to productivity. Some people still think like that. So trying to convince other people that secure coding was something that we should actually do, and trying to point out, well, look, this problem in an authentication system around truthiness, this might be another issue, was quite hard going. But what I found was what I started with was OWASP Zap, Attack Proxy, which can be used as a pen testing. You know, you can actually use it quite similar to Wireshark in a lot of ways. But actually, also, it's a very good vulnerability scanner, just a default. Yeah, if you run it in default, it will give you a pretty good scan. What I used what I did was put that as part of a Jenkins pipeline. So whenever we had a build, it would fire off an OWASP Zap scan overnight. And then, nobody wanted it to do it on every build, but if we had a release, we would run it overnight. And then if there were any failures, it would email the whole team. So it wasn't your problem, you fix it. It was, we're all a team. We should all fix this stuff. That was quite effective, especially as we would have a chain of people that were in there. So if people didn't react to things, everyone knew that we needed to fix it, and we wouldn't release something. Threat modeling was effective in a different company. In that company, it was much smaller, and we didn't really have the time to do it. I think that's one thing with threat modeling that you have to consider, and is that it can cost a lot in terms of if you have a lot of people involved in it, it's just a very expensive. If you add up everybody's salaries for that hour, it can get to a lot. But in particular, vulnerability scanning tools of all kinds definitely help. Dependency management ones so that you're not actually, it's just very difficult. You're not, the part of open source suggests that you should check everything that you import into your project. And has anybody ever actually done that? Has anybody inspected every single line of code of open source that they've ingested into their project? No, of course not. like that's the initial principle. If you go back to what people of the 60s kind of, their vision, and it's just that there's just not enough time to do that. So I think you need some kind of tooling to flag these things of, well, look, here's this bit of static code that's wrong. Did you know that you're putting in this dependency that's particularly bad? I think having that at the position of developers is really important, because then it essentially eradicates the need to kind of get to a release stage and then have to wind it all back again. I think a lot of the security tools that help are at the point that you've got it in your IDE and you can make decisions there and then. But I don't think that it's like just do that and once. I think you need a layered approach with a lot of these things. And security by design, actually thinking about things, talking them through with people, communication within a business is probably the single thing you can do really well. I find some businesses create like an us and them kind of thing, whether that be security and developers, or operations and developers, or all three of them together fighting against each other, or sales and tech. And it doesn't really help, because actually what you need to do is, if you all understand what problems are, it just makes everyone's life easier.